Good afternoon, sir. I'm Rosalinda Marie, ballesteros, and I'm going to discuss the parts of microscope. What is microscope? Microscope are instruments that are used in science laboratories to visualize very minute objects such as cells, microorganisms, giving a constructing image that is magnified. Microscopes are made up of lenses for magnification, each with its own magnification powers. Depending on the types of lens, it will magnify the specimen according to its focal strength. Next, this is the example of microscope. As you can see the parts of microscope, they had head, arm, mechanical stage, coarse adjustment, fine adjustment, and anything else. Next, who invented microscope? A Dutch father-son team named Hans and Zacharias Janssen invented the first called compound microscope in the late 16th century, when they discovered that if they put the lens at the top of the bottom of the tube and looked through it, objects on the other end became magnified. In 1667, Robert Hooke and his famous Microscopic book is published, which outlines Hooke's various studies using the microscope. Next, microscope has three structural parts. First, head. This is also known as the body. It carries the optical parts in the upper part of the microscope. Second, base. It acts as a microscope support. It also carries microscopic illuminators. Third, arms. This is the part connecting the base and to the head and the eyepiece tube to the base of microscope. It gives support to the head of the microscope, and it's also used when carrying the microscope. Next, this is the optical parts of microscope and their functions. First, eyepiece, also known as the ocular. This is the part used to look through the microscope. It's found at the top of microscope. Its standard magnification is 10 times, with an optional eyepiece having magnifications from 5 to 30 times. Second is eyepiece tube. Eyepiece tube, it is the eyepiece holder. It carries the eyepiece just above the objective lens. In some microscopes, such as the binocular, the eyepiece tube is flexible and can be rotated for maximum visualizations. For variance in distance, monocular microscopes, they are non-flexible. Next. Next, stage. This is the section on which specimen is placed for viewing. They have stage clips that hold the specimen slides in place. The most common stage is mechanical stage. It allows the control of the slides by moving the slides using the mechanical knobs on the stage instead of moving it manually. Next is aperture. It is a hole on the microscope stage through which the transmitted light from the source reaches the stage. Next is microscopic illuminator. This is the microscope light source located at the base. It is used instead of a mirror. It captures light from an external source of a low voltage of about 100 volts. Next is condenser. These are lenses that are used to collect the and focus light from the illuminator into the specimen. They are found under the stage next to the diaphragm of the microscope. They play a major role in ensuring clear, sharp images are produced with a high magnification of 400x and above. The higher magnification of the condenser, the more the image clarity. More sophisticated microscopes come with an AB condenser that has a high magnification about 1000x. Next is diaphragm. It's also known as the iris. It's found under the stage of microscope, and its primary role is to control the amount of light that reaches the specimen. It is an adjustable apparatus, hence controlling the light intensity and the size of the beam. beam of light that gets to the specimen. For high quality microscope, the diaphragm come attached with an AB condenser, and combined they are able to control the light focus and light intensity that reaches the specimen. Next is condenser focus knob. It is a knob that moves that condenser up or down, thus controlling the focus of light on the specimen. Next, AB condenser. This is a condenser specially designed on high-quality microscope, which makes the condenser to be movable and allows very high magnification of above 400 times. High-quality microscope normally have a high numerical aperture than objective lenses. Next is the rack stop. It controls how far the stage should go, preventing the objective lens from getting too close to the specimen slide, which may damage the specimen. It is responsible for preventing the specimen slide from coming too far up and hit the objective lens. And that's all. Thank you for listening. I'm Rosalinda Marie, ballesteros from Bachelor of Secondary Education. Thank you.